I see Ron Teitelbaum clapping for that. So, oh, and there's David Smith too. That's great. Everybody's here. So I think I'll start off and ask, does anybody have any announcements they'd like to make? They'd like everybody to hear. I wasn't paying attention. Do we have a topic for the next month's meeting?
Not yet. Yeah, we're looking for speakers. So
okay, so the first announcement would be we're looking for speakers for next month's meeting.
Please feel free to put something in the comment section for this meetup if you have something you'd like to present.
Right. Yep. And then we have one lightning talk. Peter Deutsch has requested a slot to present some thoughts he has. And I might ask before he starts if there are any other people who have a lightning talk they'd like to get into the schedule. Okay. And Craig, am I missing anything, or can we allow Peter to start off now?
Yeah, I think that's good.
Okay.
All right.
Well, welcome, Peter.
Thank you. It's delightful to be back in touch with the Smalltalk community, even in a small way. There were technical difficulties, and I'm going to have to ask Craig to put up my 4 slides. So the genesis of this talk was I've been doing a very, very large project in basically command line JavaScript. It has no GUI. It has no interactive capability at all. I just like JavaScript as a programming language. It's my new favorite after I switched from Python about 10 years ago. And I've been extremely frustrated because I can't find an IDE for JavaScript that's browser independent and that's worth anything. So I started thinking, well, what would I need to do to get myself, at least partway to Smalltalk with JavaScript? So here's my list of things that I'd like to have in the IDE. That I'd like to have in a JavaScript environment. And I'm not going to talk about any of the IDE stuff because I'm not prepared to tackle it. But I thought to myself, well, look, I just like to be able to get my hands on the execution part of JavaScript and do these basic things: profiling, breakpoints, trace collection, data monitoring. To do these things, you kind of need heavy-duty reflection. Not only reflection of data, but reflection of the implementation of control, stack rooms, whatever. And it seemed to me that the most direct path to get there was by doing a self-hosted JavaScript implementation. So that's what I did. Let's see. What am I? Oh, right. So the first thing I did was just kind of a stab at just doing profiling, and I did it by basically quick and dirty source code rewriting. Basically automatically patching in, tallying into the source code, and it worked kinda, but it was quick and dirty, and there's some things that it couldn't do. In particular, it couldn't include code that was generated dynamically, which my application has a fair amount of, or code that was loaded dynamically. So I said, nah, let's do the real thing. So I put together a mostly self-hosted JavaScript implementation. And exactly what that means, let's go to the next slide. So, what there is here is a JavaScript interpreter a JavaScript engine written in JavaScript. It implements our ECMAScript 5. Don't get me started on my opinion of ECMAScript 6. It represents objects directly as JavaScript objects. Objects need some additional stuff hanging off of them. So I add one additional property to all objects, and all the language primitives that allow you to see the properties of an object carefully sidestep around that one. The global environment, I basically clone it. There are issues with code that tries to patch certain global objects that I just don't address because no code that I'm interested in does those things. So version 1 just compiles to interpreted bytecode. The parser is straightforward. It's basically a top-down parser, except that it uses this neat technique called top-down operator precedence to do expressions. I've got a link if anybody's interested. It's kind of a special purpose shift reduce parser. And the parser does not construct parse trees. It uses a style. I don't know what this style is called, although it's a pretty common one, where as it recognizes each construct, it calls out to what it calls a target, passing it, basically calling a method that depends on what the construct is. I've got an add, I've got an assign, I've got a whatever, and then passing it as arguments whatever the target gave it back for parsing the components. So the compiler isn't interesting. The runtime environment is a stack machine. It uses a linear stack. It doesn't construct frame objects unless it needs them. So it will construct a frame object for closures, but not otherwise. The primitives, JavaScript language primitives, are all implemented by the underlying engine. So it's not really completely self-hosted. And the way that I handle JavaScript exceptions is that the interpreter loop is inside a JavaScript try-catch, and the interpreter loop stores its state into object properties just often enough so that if an exception occurs inside a primitive, there's enough state stored in a stable place that the primitive can in fact implement JavaScript's unwinding semantics. So that was JS version 1. It works. It's run large projects successfully. It is very slow. The engine that I use underneath is a V8. I did some early work also with SpiderMonkey, but V8 just knocks SpiderMonkey on its ass. And just before I prepared these slides, I ran 3 little bits of testing. There's the Fibonacci function, which is 100 times slower. There is heap sort, which is heap sort on an array of more or less random integers, which is 30 times slower. And then I have this very large application called DR, and the DR startup only runs a factor of 3.5 slower, but that is because a lot of what DR does at its startup is load code and decode JSON, and those are both done primitively. So that was version 1. Great proof of concept, not fast enough to be usable. So next slide, please. There was a version 2. It uses the same compiler, it uses the same bytecodes, it uses the same object and stack representation, except the bytecode is lazily compiled back to JavaScript code. And taking a leaf from Unger's work and many other people's, it's done on a it counts activations, and it back compiles when a code has been called n times, and I don't remember what I wound up setting n to. So and that actually worked quite well. The code that it compiles back to is not a duplicate of the original code for a variety of reasons. It has to maintain enough state in the right form to store state into the stack and to reify closures and to do the other things that it has to do. But if you look at the code, I mean, you can see why it's running slower than the original. The 2 places that are the big performance costs, one of them is calls. Calls are done directly, but because of the way things are represented, they currently have to be done by using the JavaScript call method for every single call. and that is expensive because, among other things, I think it's expensive because the underlying engine can't do some of its caching tricks. The other thing that makes the back compiled code run slowly is it has to do an awful lot. If it's going to implement JavaScript precisely, it has to do a pile of type checks on things like addition. So in order to, just to see what that was costing me, I arranged the back compiler so that you get your choice of precise and imprecise mode. In precise mode, it implements the semantics exactly. In imprecise mode, it doesn't do type checks on primitives like addition. And the consequence of that is that if the underlying engine has to do an automatic coercion of an argument, the call out for the automatic coercion does not go through the self-hosted implementation. It's done primitively. But if you want to be able to trace or breakpoint those callouts, then you have to use precise mode. How did this help? Well, so there is what it did for the timing. The stupid little Fibonacci function runs only 15 times slower in imprecise mode, 120 times slower in precise mode. Sort 6 times versus 35 times. And DR startup doesn't matter whether it does precise or imprecise because the startup code doesn't do a lot of the things that require those extra type checks. But 4 to 6, and I've done some, I worked with some other code. The number is sort of 4 to 8 running JS version 2 in imprecise mode. And the application that I'm working on is fairly computation intensive, and 4 to 8 would be a real drag. So where do we go from there? Next slide, please. So the thing that if I were younger and more energetic, I would want to do would be to look into do a full self-hosted JavaScript implementation using WebAssembly as the underlying, as the substrate. And it would still have to call back out to the underlying engine for primitives that can't be implemented in WebAssembly. The first one that comes to mind is date. That's probably not a big deal. But there are some other things, but it needs some other things. So I've been really out of the Smalltalk loop, so I don't actually know how Squeak pulls off self-hosting, but my understanding is that it does it by compiling down a very, very constrained subset of Smalltalk that can be compiled effectively down to machine code. And the same thing would have to happen to do fully self-hosted JavaScript over WebAssembly. Excuse me. There's a question as to whether bytecode interpretation implemented in WebAssembly would be fast enough, or whether I'd actually have to be able to compile some arbitrary JavaScript to WebAssembly the way that V2 did it. And then there's some issues with WebAssembly itself. I'd have to come up with an object representation. I'd have to do memory management. With memory management in particular, there's the issue of references from the WebAssembly world out to the engine world and vice versa. If you wanted to do GUI, there are GUI primitives, in the DOM and so on that have to hold pointers to client-supplied objects, and there's the usual mishigas with dealing with those. WebAssembly has one particular annoyance, which is that it's basically a 64-bit computation model with 32-bit pointers. And I don't mind living with the 4 gigabyte address space limitation, but it means that there are going to be 64 coercions between 64 and 32 bits, slathered around all over the place. And WebAssembly is really not well tailored for dynamic alteration or dynamic addition of compiled code. At least I haven't found a good hook for doing that. So that's where I am. There are probably better alternatives or other alternatives that people have explored out there, and I just don't know about them. I've been I've been kind of isolated from the whole technical community since I ran away from GhostScript 20 years ago. There's my talk.
Oh, thanks, Peter. Does anyone have
thanks. I think
questions?
maybe as a courtesy to Yoshiki, we should limit the current comments. If you have a significant comment, maybe save it to after Yoshiki's presentation. If you've got something really quick, this would be the time to ask it of Peter.
I'm happy to answer questions later. lpd@majorsecond.com. MAJOR, the number 2ND.com.
Great.
Thank you very much.
Thank you.
Okay, well, thank you, Peter. And Yoshiki, I think unless somebody has something else, you have the floor. The screen.
Okay, yeah. Yep. Yeah, the problem with like listening to interesting talk like this is that I forget what to talk about. So let me find. So yeah, first thing, so I am going to share my screen, and that's where my demos are. But at the same time, I'm going to send you a link that you can open and you can join into my collaborative session, and so that's gonna happen. But I need to warn you that this is a symmetric collaboration environment. So anything I can do, you can do too. But I set up my story in this space, so it's enticing that you can move around. And I'm gonna show Smalltalk code, for example, and you may want to change it. But please don't unleash your creativity in next hour. You can do it afterwards, but while I'm talking, sort of please just relax and enjoy my show. And another thing is that our software isn't that computation heavy. It's really lightweight, but at the same time, it does use the CPU constantly. And if you haven't cleaned up your laptop for a while, the dust may be in your fan and your computer may get hot. So yeah, if that happens, don't worry, you can see the shared screen. But so that's the warning I need to give you. So I shared my screen, and also I'm going to send a link here, and you can open it. Oh, and you see a dialog that says enter your name, and then press the green enter button, then you can enter here. So please try that. And yeah, wait a little bit when people come in. Yeah, the shared screen will have almost the same thing, but it's fun to go join in. And 3, 4 people. Yeah, 5, 6. Yeah, so, okay, so first of all, so the main topic I am going to talk about is our 3D environment called Croquet Microverse. But before getting to it, I'd like to talk about the presentation medium I'm going to use. So this is a 2D collaboration software we created called Greenlight. And if you drag the background graph paper part, you can change your viewport, and you can do pinch zoom on the graph paper part. You can zoom in out. And I am going to like resize. So if I'm resizing, and it's quick, but one thing you can do is, so let's say Craig, can you move this image by dragging the title bar? So while I am resizing, Craig can move it. And if you have used other software like Miro or Google Jamboard, you cannot actually do this. In their systems, you do like movement like this, and you need to wait like 1 second to see the end result show up on other person's screen. Croquet can move it. And if you have used other software like Miro or Google Jumbo,
Sorry about that.
somebody's watching YouTube. Yeah, okay. So the one thing Croquet is trying to do is to offer this real-time collaboration in real sense. And we try to build many things in this way. But here, I am going to go in this special mode that's called the presentation mode. Now, if I do this, now my viewport, basically what I see is what you see. I can move around here and your computer screen just updates. So I am going to tell a story a little bit. Yeah, so I go in sort of my personal web page here. And this is just a web page, tindizi.org Ohshima. But this has a little trick here. So if I scroll, anybody, like I said, it's symmetrical. Anybody can scroll and anybody can see where I am pointing at and what I'm talking about. So I started playing with Squeak like 1997. And for like various like lucks and some incidents, I end up with joining Walt Disney Imagineering, where Dan Ingalls worked at and Alan Kay was. So that's my start with Smalltalk. And the one notable project we did back then was called Parks PDA. So I want to talk about that project a little bit. And so in 2000, this is basically 7 years before iPhone was released. Some Disney folks thought that in the future, people would carry around like little devices, and then we should be able to show the map of the theme park and show the showtime, check the merchandise list, and make a reservation of the restaurant or get the fast pass from remote attraction and stuff. So people didn't have the real technology to support everything, but as what Disney does, they try to basically fake the experience and test it with the actual user and how they would react to it. So this is the unit we made. And actually I got the one from Disney and I don't think they kept it. So this may be the only unit in the world. But so in 2000, we went to Animal Kingdom in Florida, and we basically set up like 100 units of those. And my job was to basically take care of the lower level machinery. So every night I took out like those compact flash memories and re-flash them and reinstall and make sure it works okay. And sometimes it didn't. And so this is a moment I'm in crisis. But next morning, we get the actual cast member explaining how to use those devices to selected guests to the park. And basically we did the on-site test for 2 weeks and we gather a lot of information. And the Alan Kay flew to Florida and tried it. And yeah, so this is a picture of the family using our device. And if you go to like Disney theme park, there were cast members like this whose job is to take a picture and sell it. And he was looking at those families and, oh, what's going to happen to my job? So that's on his face here. But but notable thing I want to mention here is that even though the end result was basically the theme park navigation app, we didn't make a simple theme park navigation app. We made an authoring tool to make a theme park navigation app. So John Maroney and me as an intern are only 2 programmers in the project. And there were like 1 dozen designers. So programmers could not be the bottleneck to make a progress. So John wrote a tiny authoring tool on top of MVC, and it was its own basically UI framework. And then he basically wrote a little editor where designers can use it to link those assets together. So it was a stack of cards, and once you click on one of those buttons, it takes you to another card. So that was the content. So designers can make content on their computer by using our authoring tools, and we ship it onto those compact flash cards and then test it. So because it was fully capable squeak underneath, actually, so I want to talk about why it's a great idea to have a full debugger in this kind of environment too, but you can read the paper for those background stories. So that was my first big project with Smalltalk. And I didn't know about, I forgot to change the pictures. This one says Alan Kay. This one says Douglas Engelbart, and this is Dick Ryder and Bob Taylor. Sorry about that. But yeah, you don't have to know, you don't have to read the name because everybody knows him. I didn't know much about Smalltalk or history of computing, but I learned later that our computing revolution started from this picture, so to speak, or before, but this was one of the epoch-making things. So the Alan Kay drew this picture on the airplane flying back from Massachusetts to California. And the idea is that in the future, children would be using those portable devices and not only just consuming medium, they would be full-fledged creators on those devices. And those devices would be used or linked by wireless network, and so they can do collaboration. So if you look at the screen here and screen here, you can tell that they are looking at the same thing. That was a space war game. They are playing together, but not only they are playing together, they actually made this application by themselves by asking the teacher and by basically going to an electronic library. So that was the one of the futures he envisioned. So collaborative computer and collaborative computing was the one thing he envisioned. But of course, he was influenced by some ideas before him, before this. And one of those was Douglas Engelbart idea. And one thing, so this is NLS online systems. And one thing notable here is that even though they are in the same room working together, they are using the computers. And this was a collaboration system. But if your computer is capable of amplifying your intelligence, you would use it even in person situations. So that's the idea here. So like Zoom or 8x8, we are not gonna use Zoom when we are in the same room. That's because Zoom isn't amplifying our intelligence. It's just a glorified telephone. But if we use computers to amplify our intelligence, we would use it in the same room. So that's something I picked up and Alan picked up. And then actually Douglas Engelbart influenced like his founders, Dick Ryder and Bob Taylor, and they published a paper titled The Computer's Communication Device in '68. And this is actually, this picture was in the paper, but of course influenced by Doug Engelbart's idea. And they are, again, using computers in the same room and trying to use computer as a real thing, meaning like simulating the bridge or testing out the material strength and that kind of stuff. So that was the old ideas. And actually David here, maybe he's here. So David, our founder and CTO of this round of Croquet, he started thinking about collaborative 3D environment. And this was 94. And if you click in this YouTube icon here, you can see the video too. And then once you do it, I can jump to a time code and we can basically watch a video. So so this is 94, but David says that he started thinking about this kind of stuff in 91 or something. So we have basically 30 plus years of experience. And so check out the movie later, and I'm going to play the other one. So click on the YouTube icon here. And this is the first Croquet. This was a video of Alan Kay and David demoing the old Croquet at Computer History Museum. So again, we have some history of trying to do collaborative creating on computers and in 3D environment. So this was 18 years ago. It's a long time ago, but we sort of try to carry the torch and trying to do it one more time. So that's our current Croquet company. Yeah, please visit like those pages. You can see our website. And I'd like to talk about what as far as the network topology or network architecture is concerned. I'd like to talk about what's different there. So the one idea, typical way to implement a multiplayer system is that to have a strong, expensive server on the cloud, on the internet side here. And then those views or clients, send an event to the server, like my mouse movement or anybody's mouse movement to the server. And then the server computes the world state, which could be a huge data, but people say, internet is fast enough. Let's just stream down the large amount of data and the view can update. So that is typical way of implementing. But Croquet tries to be different and be more efficient. So the idea is that instead of trying to compute the next world state on the internet side, we just send events to, actually I should show this. We should send events to the little server we call edge reflector. So edge reflector does not compute the new state, but it just put timestamps on those incoming events and reflect the events back to all participants. And on each participant's computer, there's a shared computer that computes the next world state. And we basically make sure that that computation reaches to the exact same state. So in some ways, this is sort of tied to what Peter was talking about. But our virtual computer isn't a real VM. It's just a JavaScript engine with a little bit of patches in libraries. But we ensure that the next state is identical. So we don't have to send the large data from the network, from the server to client. Just the client computers compute the next state and locally they can update view. So that's how our network architecture works. So we try to build few more things in this environment. And it can be very simple, like this one. And so this is just really a web page, but it has a Croquet application. And I'm going to load it here. And is it doing it? Do it. So this is a simple application, like 300 lines. But if anybody can move a red dot, please actually do move a red dot. so that your computer can play sound. So it's going basically 2-second loop playing do re mi fa sol la si do, do re mi fa sol la si do. So I can make a new note, and so I can make a bass sequence like do, and somebody else can make a melody over it, for example. So, and the one thing we can do is I popped out the QR code here. And if you scan the QR code here with your phone, and the same thing will run on your phone here, and move a dot on your phone, and how real time it is, how low latency it is. So this is the Croquet's technology. Yeah, Mr. Steve likes it. And this is the underlying technology here is very solid. Vanessa Freudenberg and Alan Lanza spent a lot of engineering effort to make it robust. Sorry, I'm gonna close it because it's noisy. They spent so much genius engineering effort to make it work robustly so that other people like me can build more stuff. Oh, I shouldn't have closed. But this is a Smalltalk demo, a Smalltalk meetup. So I'd like to show you a Smalltalk demo here. So this is I should make it bigger. This is a little Smalltalk demo I wrote on top of Croquet. So this is sort of the Ian Pumata's Pepsi-like syntax, but I say selecting Control S here. I hit Control S. Now the system compiled the Smalltalk code into basically my JavaScript runtime, and I am going to execute this sort of do it thing. Ooh, maybe I don't have to select. Sorry, not do it. I say save, and I got a blue because initialize says this created a new morph so-called, and it has a width is 50, height is 40, set the background blue, and the add event listener for click with on click, which will be executed here. So if you know how to do this in your browser and open the developer console, you can see that this blue thing here is actually a div element, and it has a background color blue and width and height are 50 and 40. But as I said, if I click on it, it executes on click event here, or event handler here. And this one says, make the width 10 pixel bit wider, at the same time, change the angle a little bit. So I click on it and it rotates and grows. And somebody can click on it, keep click on that. But while somebody is doing it, I can change the program here and save. And then the rectangle goes other way. So this is, and actually anybody can edit here. It's a collaborative text. And it's a collaborative program is sort of possible by just in any language, so to speak, as long as the model matches up with the Croquet model. Yeah, so if you resize the window, the resizing is visible to everybody. So yeah, nothing wrong with it, but just to note. But as I said, so you can Croquet network infrastructure allows you to make many different applications. But what we are most interested in is 3D environment. So let's open that here. And I am going to open it in the environment. Oh, didn't copy it. Copy and paste. And let's say, make it bigger. Yeah. So now it's loading a 3D environment here. And this is sort of like a campus map. And so, there's a large circle at the bottom center. And if you drag that circle at the bottom center of this 3D environment, you can walk around. So I am a Cheshire Cat. So if you see I am moving around, that's because I'm moving this dot at the bottom center. And so in this world, yeah, actually, you can, if you like to, you can open this on your cell phone to scan the QR code if you like. But here I'm going to again tell a story. So let me go into the presentation mode, and please sort of keep the joystick away from you, so to speak, because if you move, you are going to leave my tour. So this is campus map, and there's a secret corner around here where the lazy students gather and play. And here there's a radio controlled car of Porsche, and that's going in circle. And there's an earth that I can rotate. Anybody can actually rotate, but their behaviors are written in this program here. So for the earth, or let's say for the car, it's called a drive actor. And basically in setup, it initializes properties like speed and angle. And then it says on key down, call the method called control. And in control, if the key is arrow right or arrow left, change the angle. If it's arrow up or down, change the speed. And basically the run method here is saying that in the 20 millisecond future, in 20 millisecond in the future, call the same run method again. And then, but at the same time, you rotate by a little bit is the angle, and forward by, which is the speed. So that's why this guy is going in circle like an e-toys. But if we look at the spin thing, this earth thing says whenever spin happens, do spin and or new angle. So this one actually publishes a message called new angle whenever its angle changes. So that makes us think like e-toys. Oh, this one is publishing a message called new angle, and this car has something to do with rotating. So if I change this this program to say I will, oh yeah, don't change code yet. Selecting is fine. If I receive the message called new angle, say subscribe, and when message comes in, let's say change the angle here, this dot angle. So I save and I pull back, I take everybody here. And I started spinning my car, or spinning the earth. And then based on my spinning the earth, the car rotates. Oh, that's cool. But let me take everybody here. But as e-toys, this car is spinning too fast and it's hard to drive. Oh, somebody, I said, don't do that. Oh, it came back. This car is very hard to drive. Oh, and that's because we are using the incoming angle by itself. How about if we divide it? And this is, me as an elementary school children, in the first time in my life, or maybe division has some useful feature. So I divide the incoming angle by 20 and save it. And I pull back and I rotate the earth. Oh, now it's much easier to drive. So this is a live programming environment, collaborative. And then, designers, you can invite designers and the other game sort of testers and say, what's the good parameters? And if you have written a game like this, you know that there will be many fudge factors like this 0.04 or like this 0.025. And until you tried it, you wouldn't know what would be the right like value. And if this is a collaborative system, and if you have to update your server because this logic lives on the server, and if you join into that newly deployed server every time you change like one number here and try it again, its turnaround time would be minutes, right? But as Smalltalk, we all know that if it's a live program environment, changing a number and say Control S, and it's gonna take the effect in real time, and not only for me, for everybody. That's the environment we want to have. We are trying to make one like that. And I am going to move to a different place. And oh yeah, this is a physics simulation. So if I tap it, I'm going to take everybody here again. If I tap it, this pendulum swings. And if you have your cell phone opened, you can really see that this swing is totally synchronized on your computer and your phone. Or if you open two windows, you can see that they are synchronized. And here, there's a sort of, this is a technology college. So some students who has a lot of free time set up some physics simulation here. And it's spewing out different shaped objects, and it's doing the gravity simulation. But one thing, one of our ex-colleagues told us that, you know, it's nice to be able to live program, but if you are a professional programmer, they are not gonna use, you know, they are not gonna use that rudimentary gray text editor in this world. They would need to use their own text editor. They often have like religious conviction that which text editor is the best one, and they need to use it. And I said, like, yeah, okay, let's do that. So actually, let me make them a little bit bigger, both of them. So I am, yeah, so it's not hard to do because we set up a new, basically the object model that's conducive to live programming. And the programming elements are basically transmittable over network. So why don't we transmit the changed program on my disk to this session and just edit it. So this, I am on the right, I am sharing my text editor, in this case Emacs, because that's the best editor. And I say connect to my local server here, connect. And so this demo here is Microverse behavior campus. Oh, I have like 1 more hour, right? Basically, for 30 minutes. This isn't the end. So this is the actual program that's running. Oh, somebody stopped it. Yeah, actually, there's a quick event on this spray thing. I should probably make it bigger a little bit. So this is like let's see, like 400 lines of code, and this is my simulation code. So here, basically, we have the model view separation. So we have to specify what really should happen in logical sense in this code called actor. So actor says, let's say, when we are making the ball-shaped thing, we create a Rapier physics engine's ball-shaped collider. And when we are making the cuboid-shaped thing, we make a different collider called cuboid. And we set up a few things in there. And actually, if you click on the stopped cube, you can give it a jolt and sort of trigger some jumping behavior like that. So yeah, so it's written here. But on the view side, so as I said, there's a model view separation. And on view side, when we are making the ball shaped thing, we create a 3JS sphere geometry and set some material. And when we are creating the cuboid shape, we create a box geometry and basically instantiate our 3JS mesh with that. And so the one thing here, spray is that is spray actor here is this gray thing at the top, and this it creates a random color method by this random color method. So I create a random number and use it as a hue, and with a fixed saturation and the value and compute RGB value and return it. You can read it, right? Maybe a little bit small, but let's say I invite a designer into this collaborative session, and she says that, oh, we don't want to have different color. We just need one color that is red. So I returning 00, oops, if it's 00 here, and I'm going to save this file onto my local disk here. And now on everybody's computer, now we only get red things. Oh, and she might say, no, not red, actually, let's go to green. And now it's all green. And yeah, that's fine. But, but yeah, like tweaking parameter is fun, but what we want to do is to create like a new kind of shape, right? So this isn't, we used to, if you know me, like I used to give a lot of like hand waving demos, but this one is in my mind is a real thing, meaning that actual programmers can use it to develop stuff. And I do use this feature to develop stuff. So let's say I want to have a cylinder shaped thing in addition to ball and cuboid. So yeah, as I said, on the model side, we need a different shape cylinder, and that would say a cylinder collider. And I saved it, but nothing has changed because it's only the model side. And I go into the pawn program, the view side program, and the view should say when the cylinder type shape is specified, we should make a cylinder geometry and instantiate. And I save this to my disk, and nothing has changed because nobody is telling us to make cylinder. But here, so there's a random, instead of random color, there's a variable called dice, and that's getting random number here. And if the dice is like 0.01, less than 0.01, so once in 100, there should be an earth created. But if it's 40% of chance it was creating cube, and rest of time it was creating a ball. But let's say we want to make a cylinder shape here too. So between 40% to 70%, we're gonna make a cylinder. So I am going to save it here. And now we get a cylinder shape. And so as we talk and we ask opinions from other people, we can make a different object like on the fly. And I wasn't enabling the syntax highlighting here, but let's say fly check mode. Yeah, so this is a real editor for professionals. So it has all syntax highlighting and all those squiggly lines. And if I have a syntax error, it's gonna tell me and all sorts of stuff. And if I have an error in the model side, it often is okay. All models will raise the same error and go into the same situation. And I re-edit like the model side code again. It's gonna be it's going to reinitialize the system, not the system, this particular object, and it tends to be okay. And on view side, it's okay to make an error sometimes, as long as you make like nonce or infinity and stick those numbers in 3JS matrix. That tends to kill the 3JS, and you might have to restart. But restarting a session isn't too crazy. If you just type in a new session name here and just reload, that you get a new session, and you don't lose any work because all your changes are on your disk. It's like a changes files in Smalltalk, so you don't lose them. So so that's what we can do. And the one thing I want to show, somebody has already opened the portal. So let me take everybody here. So we have a portal feature, and also what we want to do. Sort of a little bit of stuff, background stuff about Metaverse. So I am showing just one of those articles where people talk about the Metaverse. And there you can find many articles on Metaverse, and basically you can get the idea that what they want from the Metaverse world. And so, for example, this is pretty good article. You don't have to believe everything everybody says. But if I skim, if I condense the main ideas here, basically there are three things people are interested in. And one is this Web3 thing people talk about. What they want is a decentralized sort of internet. So anybody out there can make their own world, and not like a single company dictates what to do and where to put and what you can do. So anybody should be able to make their own worlds. But this is on internet, so you still want to loosely connect those worlds. So it's like a hyperlink on the web. You make your web page, but you still want to link to somebody's page without getting a permission or anything. So that's what people want. And another thing is that like NFT. So NFT craze is gone, thank God. But there's some good ideas around it. That is that digital artifacts are inherently like copyable and sort of no cost to copy. But sometimes you do want to have some identity associated with your digital object and say, this is my object, or this is your object. So you kind of want to have some features to say, this is like one immutable thing. And you sort of transport it from one world to another because they are loosely connected. And another thing is basically creation ability, get back the creation ability, give the creation ability to people. So people want to talk about, creation of new Web3 things should be democratized. So anybody should be able to make stuff, not only Facebook users. So that's the ideas behind it. So I was talking about a portal, and then, some people went into this separate world. So I am going to cross this threshold from my campus world into a gallery world. So you can come in to this new world, and if you are running it on the browser, the URL would change. In fact, you do go to a separate web page, but only loosely connected. And so we have a portal mechanism that connects separate worlds. And so here's another physics simulation. And this is a PDF viewer. I will take everybody here. So this is a PDF present. If you want to emulate old media in this new media, you can put a PDF in this world and you can do presentation here. And this is a collaborative text editor, so you can edit together. And so 3JS can have some tricks. So if you are on your own, so this statue, we got an award at the AWE exhibition. But this statue is looking into me, right? But if you have a separate avatar and go side of me, this one will look at you too. So it's a billboarding happening. So if you, the 3JS logic here is controlling how it's presented. So, and this is actually getting the actual real-time data of Bitcoin. And the one problem, if somebody is in the campus world, they go to, actually, let me reload so that everybody can come here. So oh, not campus, sorry. I meant to go to T4. Hey, sorry, I'm trying, somebody's clicking on, trying to take everybody to my gallery world. So because web can do anything, web application can do anything that browser can do. So on browser, you can fetch some data stream out there feeding us the Bitcoin price. So we get the actual Bitcoin price and visualize it in this way, for example. So it could be any data. Any data available on the web, you can fetch and feed it into your Microverse world. And also, if you have like REST API endpoint out there, like clicking something could trigger that endpoint, and we can actuate like physical object outside from this world. So you can do anything a web lets you do. And oh yeah, so one thing is about getting the object portable. So I want to show two things. So I created like a heart-shaped 3D object. So I am dragging a file that's a sort of the packaged immutable object into this running session. And I got this heart in our world. And if you click on it, anybody can click. It does throbbing behavior. Somebody keep clicking it. So it's supposed to do it 3 times and stops. And this is basically like 40 lines of code with a lot of boilerplates. But I can show, the heart of the program, so to speak. So I'm opening the editor for that object. And what the main thing here is that, in this animation loop, it sets the new scale, which is computed by this get scale method. So it's basically the 3000 millisecond loop is there, and it does the 3 triangle wave. So it goes up, down, up, down, up, down, and stops. But I thought of this, and it doesn't look like real thing, and that's because when the heart is contracting, it's fast, right? It contracts fast and it expands slow. So we should do that instead. So instead of trying to make up this triangle shape, it should be a sawtooth wave. So I would return for half. Yeah, we don't need half actually. So the period is 1000, and third is basically the remainder of the period. So actually we just return third divided by period. Oh, not period, semicolon. And I accept code here and click on it. Now the contraction is fast, expand, slowly contract. So you can change this kind of program, and you can re-export as a new immutable object and send it to your friend. And your friend can load it into their world and use it. And yeah, so this is about basically portable objects. And I want to go into a different world here as the last thing. And if I open the new portal and I try to take everybody into the new world, and I just want to show one thing here. So or maybe people didn't come. Sometimes this happens. I'm going to change it by hand. Factory. Yeah, so I have this sort of, this looks like a factory of drones. I'm taking everybody here. And there's one going in circle, like my radio control car. But one thing, it's basically doing the same thing as the radio controlled car, saying scheduling the next step, but saying at the same time you do rotate by a little bit and forward by a little bit. And this extra code make me stop it if I click. And we try to make it a no-code environment, so I can open the property sheet here. And sure enough, it has a behavior we call those attachable thing called behaviors, and we can attach them. And also we can duplicate the object, duplicate, 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 like this, and let's delete the original. So all these duplicated objects are following the same program. And yeah, somebody closed the property sheet, I think. But so one thing, this one says forward by a little bit. In this case, I'm gonna take everybody here. Forward by a little bit, in this case, positive 0.03, but I am going to change this to negative 0.03 and accept, and imagine what's gonna happen. So they are going to go backward, but not this way, they go this way, because that's what it means to have the same rotation. So if you know Squeak and what I did in Squeak, there was a thing called Star Squeak, but for my work, I did a thing called Kedama. Back then we could only make those little pixels, like one pixel thing, and we control those pixels from our program. But now I am controlling drones by my program in 3D environment. So that's that. And so if you have a relatively new iPhone or any phone, nowadays you can create your own 3D model that easily. So I am dropping in a model I scanned recently. This is my avocado stuffed toy. And this doesn't do anything yet, but I can open a property sheet and I say, it should go in circle too. And I say, apply. And now it goes in circle. When I say, it should do spinning too. And I say, apply. And I can spin it too, like this. So it's really trying to be a no-code environment where, programmers write 40 lines, 30 lines of programs to spin stuff or rotate stuff or, scale stuff. And the end users can attach those behaviors to their models they scanned with your phone. So that's the environment we have. So yeah, you can go to croquet.io Microverse, and actually you can check out our GitHub repository and modify stuff. And you can have your own world, and it has those nice properties. But let me sort of conclude perhaps in last 10 minutes or so. And one of the things I'd like to talk about is how we got to those ideas. And that's basically techniques that made 3D live programming possible. And one is a custom object extension mechanism. So first thing I'd like to talk about class or object extension mechanisms. And there are a bunch of mechanisms to add like new behavior to your existing class of objects. And we can go back to mixins and traits. We can talk about expanders or context-oriented programming. And those are basically ideas that instead of like making the catastrophic or the global change to your class hierarchy, you attach a little behavior to a class or object and just customize a class without breaking other parts. And so if you look at those other languages, so if you look at Scala, they say they have traits. And if you have PHP, the manual says they have traits. And if you look at the Rust, they say they have traits defining shared behavior. And this is obscure language, but if you look at this language's manual, it says traits. And in this language, they can say R cubed in this way, actually. And not many people may know this language. But this is Fortress, one of those first languages that adopted this line of traits. So traits, and those ideas are basically originating from this particular one. So traits as object class extension mechanism existed in other forms, but this particular line of sort of the lineage goes back to this particular traits, and this is Nathaniel's work and others. And actually, so when I was doing the internship at Disney, Nathaniel was also doing the internship at Disney, but I was doing the production or the experimental stuff. But Nathaniel was doing the actual programming language stuff like traits at Disney. So I was sort of admiring his talent and his work from side, and this created nice, clean system so that even the statically typed languages can adapt. But actually, Alan Kay had a little bit of different ideas on here, and that was like this. And as you know, this is etoys, and there's a blue car have a method or script called square. And if you click on this thing like 4 times, it's gonna draw a square. And blue car also has a circle script, and it's forward by a little bit and turn by a little bit, and it goes in circle. And one thing etoys had was a category of scripts. So those scripts are in this category called scripts. And this is sort of visual manifestation of what you have on this object, or visual manifestation of what this object can do. So what Alan was talking about was that, and another thing is that those little features in those scripts, they are using the base object features. So what Alan was talking about is, this is like a composable behavior. Why don't we able to just drag out this category? It's a set of categories. It's like your micro world. Why can't we drag this out and drop it onto this other object? And then suddenly this other object gets the same set of behavior methods. And we didn't, sorry, Steve, we didn't get around implementing this in etoys. But that really left me a strong impression. And that's why we have it in Croquet now. So that's how it is. And also another big inspiration was this Pi paper by Goldstein and Bobrow. You should look up, and that's what we try to do too. And I'm not going to explain it in deep, but so our Croquet's behavior system is a basic cross of all those nice ancestors ideas, especially Pi, and also including this etoys ideas we didn't implement. So that was one of the big things that enabled us to have these attachable behaviors. And another thing I'd like to talk about is this custom, or what it takes to make a new application framework that does what you want. And very early, I talked about the Pax PDA. We made a custom application framework. So that was the idea. I didn't know what you can do back then. But since I saw it, yeah, like making an application framework for your application is something you should do. And then I looked at over time many application frameworks like Squeak MVC. That was old, and I got to know it much later than I knew about Java AWT and Morphic, then Smalltalk and stuff. But those good ideas are there. And what, however, I found or I experienced was that, reading papers and sort of reading documentation of those frameworks is one thing, but you get your hand dirty and learning about those frameworks were pretty much different things. And especially it is important that you need to learn from masters. So I was very lucky. This is really lucky thing, like John Maloney, Dan Ingalls, Andreas Raab, and those people who actually, Dave Smith, those people who actually made application frameworks for their applications. It's not easy things to do for them even. They need to do a lot of experiments and, hitting the dead end and come back and try different things. But unless you see what those, gurus do and witness it by yourself, you wouldn't know what's like important ideas or when to know to take the different path and stuff. So I thought, as just a regular programmer, but being lucky enough to be embedded in those environments, I was really lucky to know how to write your own application frameworks. So that really helped me to design and implement the Croquet Microverse framework. So that's really written by us and designed by us, and has some important features that only make sense in collaborative environment, for example. I forgot to put the blog. I forgot to put the links to blog entries my company has, but you can find them and you can read about what I talk about here on those blog entries. Yeah, that's pretty much it. And this part, I will talk about this part. And this is highfalutin idea I don't deserve to talk about, but I am going to talk about. So this is basically 8 pictures organized in 4x2 matrix, and top row here describes the actual hardware form factors. So how those hardware actually looks like. And the bottom row here says that what are they like or what they compare to. So what it is like. So the Engelbart said that the computers before him, like mainframes, IBM 1401 or something, those computers were like railroads. You cannot decide where to go by yourself. You need to negotiate with other people, and some other people decide when this thing goes, and you can go to places where other people decided. But Engelbart said that what they wanted was something like automobile. That was like, with a little bit of training, that killed the NLS basically. But with a little bit of training, they can decide where to go, when to go, and it's fun to drive a car, and you can go places with your friends. So this was like more mobile, and that's what they wanted. And some computers, you can say, it's like, instruments or tools, basically. That's what people say. PDP-1, it helps you to do experiments. It helps you to make stuff. So it's like tools. But what Alan Kay was great about was that he said that it's not only tools. It's like media. So it's like a book, and you can communicate new ideas with it. But it's not only just communicating ideas. On this new media, Dynabook, it's a dynamic medium. So you can change how you want to communicate your ideas by yourself. So you can do it from the book itself. So that's the basically self-modifying, self-improvement idea involved. So you can make new medium from within the medium. So that's something he said. And the laptop I have here, like cell phone here, the form factor of those are still the rectangular thing with display and maybe keyboard, and you do stuff. And so this is the form factor of computers we typically use. But this idea of that is meta medium, it's not totally realized yet. And of course, we have this the 4x2 matrix, but people naturally curious about what comes next here. And the form factor part is kind of easy because we have it. It could be like, glasses, it could be watches, it could be just a little thing in your room and you talk to it. It says, it tells you tomorrow's weather. So the computer's form factor will be invisible, and they are getting invisible. But what we don't know is what it is like here. And it's not easy because it's not, there is no single right answer. It can be many different things. Like this computer is a book, but also different things. So my hope is that we get a very good analogy for what's coming. If we don't get a good idea here, it could be just a servant, or it's like it's just a convenient slave of you. Or it could be something better, like your friend, or it could be really something amplifies your intelligence. So that's something we want to have. And while I'm using JavaScript mainly, but those ideas are not language dependent. But if I didn't use Smalltalk, I wouldn't be here, first of all, but I wouldn't have those ideas here. So like, Smalltalk, self-modifying stuff, and make a system by yourself. And all of those ideas taught me what to talk about, this kind of stuff. So yeah, thank you for giving me the opportunity to talk about my ideas here. And please do try Croquet.
Yay. Thank you.
Yep, thank you. So
Nikolai? Sorry. Nikolai, you have a question?
No, yeah, question and answers time.
I'm sorry. A very impressive presentation. Thank you. I'm just, I really was inspired by the Croquet from the first time, and I was inspired by the portals. I'm not here. Oh, sorry.
No, I can. Somebody just did a sound effect, but you're on, Nikolai.
Yep.
Maybe.
I'm here.
Sure.
Yeah, go ahead, Nikolai.
Yes,
Oh.
it's okay. I'm trying to be more loud. I'm here. It's okay.
Mhm.
Thank you,
Okay.
Yoshiki, for your presentation. And I'm just trying to ask you about maybe more about portals, because, for example, by myself nowadays, I'm also experimenting with the Croquet architecture and trying to make different experiments to look into Smalltalk version, where was the portals and where you could interact by making recursive mirrors and so. Maybe could you say something more about this? About because what I'm doing now,
Sure.
for example, I try to implement them in using functional reactive programming, and actually I have some really success in this. But maybe you could say more about how it is in your.
Yeah, okay, just a little bit. So Vanessa, David got on this idea, I think, originally, and Vanessa implemented. And so if you come to my screen share or green light, you can see the portal. So let's see. So in this version, as I talked about here, people need to have loosely connected words, not strongly connected words, like WebLink. And the idea here is that if you look at my screen share in green light, I'm clicking on the full screen button with Shift. And you can actually see that those two are iframes. And you see this hatch pattern here. Oops, I clicked on it. Hatch pattern here, meaning that it's just a transparent. So in this way, it's actually two iframes in front and one back, and you are seeing through this transparent area of the iframe in front. So the really iframe is a separate JavaScript execution context. So we actually wrote the entire new Microverse environment in this iframe behind, and we are seeing it. That's how it's implemented. And this way of doing has a downside, like it takes a lot of memory and CPU time because we are effectively running two sessions in your browser tab. And that's why it doesn't often work on iPhone yet. But, it's the way we do to satisfy this loosely coupled idea here.
Exion?
Yes, you call? Can you
Yeah, I
hear?
can hear you.
Did I do something wrong?
Oh, you're good.
No. Yeah, go ahead and ask a question.
I wasn't. Oh, is it because my hand is up?
Oh, yeah, yes.
All right, maybe that was a mistake. Lower my hand.
No.
Okay.
No. Maybe you should ask a question.
All right, maybe
Now,
all right. Since I'm presented to do this, this background, this 2D view thing that you have, is it part of
right.
Croquet or is it?
It is an application written in Croquet. It's an application. Croquet is a substrate, and this application, Greenlight, you can actually use it if you go to Croquet IO Greenlight and register. Yeah, this one. And this URL. Oh, did you come later, perhaps?
Yeah,
We are actually sending this link around. I see.
I did come a bit late.
So if you open this second link here, you
Now,
can actually go to this session.
It's nice to have that, but I like the sort of the alt tab capabilities where you have, you use alt tab to go from one window to the one behind and back. Does this green light have that capability?
Not yet. We talked about it, and Greenlight is open source. Actually, you can implement it relatively easily. However, those are in each of those. Most of those are separate iframe again, which means that it's a separate DOM tree, separate JavaScript context. So let's say if you can see that I can select. I'm selecting text here, right? And then, yeah, if I say hit tab or alt tab even, which one should handle is a question. And if like inside one has something, we cannot handle it outside. So from our experience, many things don't work as expected if you embed more stuff. So that is half of the reason why we don't have tab and go to next window here easily. But you can implement it, and you can, for example, this is a picture. This isn't an iframe. So you can easily make up a world where you have a bunch of images. You can drag and drop images into the environment and have a tab to go to the next image, for example. You can make that kind of stuff.
Thank you. Very interesting.
Axel?
Somebody's on.
Yeah, hi. Great talk. Thank you. I have a question about debugging. How does debugging work in this universe where you have lots of concurrent object event loops and people looking at things? Does every event loop get bugged, or how does it work?
Event loop. So let's say this, we are not deviating from the baseline JavaScript at all. So the JavaScript engine in the browser is basically event-based. So when mass event happens, it handles and goes dormant. And you can have timer event, or you can have an event that fires at every display update, which is what we use. And at every frame update, and there's a limit to 60 Hertz, we process all incoming events update. Yeah, I can go back to this image if you can see it. So the virtual computer here receives events from the reflector and also timer events and stuff. Oh, no, let me take it back. The virtual computer receives events only from the reflector. And then at every animation frame, it processes basically the queued events, update themselves, and render screen. So that's how this works. And this is actually the separate iframe. You can run it in your phone too. For example, if you scan this QR code. And so the idea is that this little thing embedded is its own separate world. So it does the processing and updating screen. And that's totally independent from Greenlight or the Smalltalk example or the Microverse here. So they are separate JavaScript context.
Okay, but how do I do debugging? I mean, is there like an equivalent of self-help? Does a debugger pop up for everybody who is in that shared world, or how does it work?
Also, yeah, it doesn't do that. In this way, if you are looking at my screen share, you can see I opened the console, but you cannot see the console if you are in the Greenlight. So what's going on? So let's say I go back to, default is fine. So there are a few ways. So I am editing the code in my text editor, and this is the default word, right? So behaviors, default, and there's a file called let's say, bouncing ball. I opened it. For some of you should be able to see it. So bouncing ball thing is controlling this thing. So the up every something, it updates position. Let's say, yeah, I want to debug. It doesn't do much, but I want to debug on pointer down. So as a regular JavaScript program, I wrote debugger inside. I make sure I'm connected. And I save it. And then I click on this thing here. Oh, doesn't. You know what? This may not be using this anymore. It's supposed to hit the debugger in my environment. So the basic idea is that you use the. Did I actually save it? Use the Chrome. Oh yeah, here you go. Chrome debugger mostly. So P3D is my pointer down event, and it has those coordinates. And oh, what's UV? I am hovering the p3d.uv in my developer console. If you look at my screen share, and oh, those are values, and I can step through and continue. And this live session is still ongoing. Oh, I clicked it again. So this is the collaborative. And as long as you don't pause in debugger for longer than 30 seconds, you can come back here and do it. So this is a typical way to debug it. And you can simply have a console.log p3d plus hello or something. I saved it. And if you open your developer console, it should say, oh, object hello, if you are looking at my debugger console. So this is really no fully involved JavaScript, basically, with a little bit of stuff added. So that's how I debug it.
I see. Thanks.
Mr. Steve? You'll have to unmute.
We still cannot hear. Oh, one moment. His hand gestures are very expressive.
I think I can unmute him also. Oh, hold on a sec. Oh, interesting. I cannot. Only Mr. Steve.
Okay, I found it. My
all right.
head's keyboard icon was hiding me. So Yoshiki, good to see you.
Good to see you.
Can you show me how you dropped behaviors, like took behavior from one thing onto another? I sort of missed how you did that.
Oh yeah, I forgot to mention. The main thing is to hold down the control key and click. Or if you do control drag, you can move. But main thing is to do control click.
Could you like demonstrate real quick on something? So I get
Sure.
that.
So in green light, if you go to green light, you see that I am looking at the heart.
Yep.
So I am holding down my control key
Mm-hmm.
tap on the heart.
Okay, so
I
it
got
opens up the
this
browser.
property sheet.
Property sheet, okay.
Oh, sorry, okay, this is a problem of using airport. Can you hear me?
Yes.
Great, yeah, okay. So this list on the right here, circle parting right, those are available behaviors loaded onto this world. And in this case, this heart has a one called throb. And many others are not useful for this one, but let's say I turn off throb by clicking and say turn on spin, and I say apply. This doesn't have any feedback. I click on it, and now instead of throbbing, you can turn to it spins. So that's how you attach and detach behavior. Select available one.
Oh,
It doesn't one
okay.
from the list and say apply. And
So
if you load a new thing,
Mm-hmm.
let's say I have a new thing somewhere here. Where did it go? Flip. Let me look up. Flip. Oh, I lost it. I created a different behavior. So either you can drop in the bars file, which you can create by clicking on save
Mm-hmm.
in the property sheet, and that creates a file, and you can drop that onto that.
So-
And
so-
that has a side effect of adding the behavior to the list of available behaviors to the world.
Oh, the property sheet. Those are the behaviors available to the world. It's not
Right.
so it's not sharing behaviors across objects. Like I can't create a behavior on an object and then share that across, or well, I guess it's in the world.
So creating a new behavior, yeah, you basically have to resort to the text editor on your
Okay.
local computer first, but you can dynamically load it.
So then, how do you make these objects, and like how do you have like a parts bin and make them discoverable? Like how do I know?
Well, yeah, great question, and that's where we want to go.
Mm-hmm.
And the underlining features are there, but we do not have good parts bin mechanism yet. But again, this is something you can make. Actually, it's open source, and you can make a behavior to make parts bin actually, and you can debug it in the world and do it. So we
Thank you.
have to do it, and but it would be great if somebody other than Croquet folks do it.
Thank you.
No, I cannot hear Craig. Oh, maybe.
Oh, sorry. Thanks, everyone, and thanks, Yoshiki. I think maybe we'll have just a few more minutes until the top of the hour of open discussion, but then I need to end the meeting because I have to get on to something else.
Yeah, I stick around a little bit.
Yeah, just like 7 minutes or so.
So Yoshiki, how can we support you and the Croquet team with this wonderful work you're doing?
Yeah, so good. Yeah, in any way you can, basically. But it probably comes down to dollars right at this point. But using it, so yeah, you don't have to, it's actually about, so this is a startup, and this time around it's a for-profit company. But it's a startup in tech world, meaning that if we get users, even non-programming users is fine, they can make a world and put your own stuffed toy or the clay model a child makes, and you put the behavior. And if the investors look at those traction, they would, in theory, they would give us money. So the traction is what we need, basically.
Got it. So FYI, I'm now at Verizon, and I used to work in emerging technologies, and I know you're working. Like mech is a big thing because you want to be on the edge.
Oh yeah, okay.
If you need an introduction to some of the folks over there, reach out to me.
Yeah, actually, Verizon, we do talk to them, and we have some good conversation. And actually, I think the part of, so Verizon has an in-company convention, and I think Croquet was shown in the last installation of Verizon convention.
Okay. I'll message you on LinkedIn or something and see if I
Yeah,
can
that would be
help out.
great. Yeah, it's
Cool. Okay. Well, I guess I'll close the meeting. Thanks everyone for coming.
yeah, thank you.
And please join us again, second Wednesday of October. Speaker to be announced.
Thank you.
Oh, hey, David. You are there. Okay, yeah, thank you, everybody.
Bye.
Yeah.
Oh, but no, I stick around again. Oh, no, if you're closing.
I can be here another 4 minutes. Yeah.
No, oh, you have to be there? Then no, we leave.
Yeah.
I guess the king has to be here.
I just wanted there to be like a decent ending point for the video.
Yeah. Okay, no, yeah, thank you so much, everybody. And yeah, let's conclude it.
I noticed that some things that you were showing on your screen were slightly different on mine. For example, the very title, California Smalltalkers Meet Up, in your screen was a single line, and in my screen the up was on another line.
Oh, interesting. Yeah, it's a.
So my question is, if since would that make a difference if we're trying to click or the underlying JavaScript knows that?
So for that thing, that's the view side thing.
Yeah.
So as long as the view detects a click, like the model doesn't know if the layout is off, and that's most likely that somehow your session failed to load font at the crucial moment. It usually doesn't happen, but it can happen. If the font didn't load, the metric goes a little bit different than just it can wrap the line.
Another place where there was a slight difference is when you showed the property thing that has the two columns. For me, the right column was narrower, so some of the items were overflowing it. But
that like this, it's on purpose. If you are staying green light. Oh no, I should share my screen.
So on your shared screen, the rectangle was the right size. It was as wide as the widest thing. Yeah, that one. For me, the right rectangle was about half as wide. So the wide item was overflowing it. But
really?
Yeah.
That's interesting. Okay, thank you. Right rectangle, you mean in the 3D environment, in the propagation?
Yes, exactly. So I was seeing it exactly like this on your screen, and in my screen, the left rectangle was exactly the same, but the right one was narrower. I thought, well, why would that? That's
I
weird.
Cannot tell why that could happen, actually.
If
actually, no, sorry. Yeah, if it's a different font, but theoretically, if your browser failed to load that font also, yeah, sure, that could happen.
I was doing this on Firefox, if that makes any difference.
Oh, Firefox.
Yes. So I was.
Okay, I should work, but didn't try.
So I was just wondering if that would make a difference, like if we tried to click, since if the visual is slightly different, then you might click on the rectangle and I might click off the rectangle, so you select it, I don't. So
yeah, so the answer is no. So the model view separation comes in play, and the click would happen on the view side and the propagates to the model. And those events have coordinates, and that can be off, but your model shouldn't use the raw coordinates anyway. That would diverge the model. So
as long as your model program is written carefully, that shouldn't be a problem either.
Great.
Well, sorry, all. I have to go now.
Yeah,
so
okay.
I'm gonna end the call. Thanks again, everyone.
Thank you. Bye.
Bye, everybody.
Yeah. Bye.
Thank you. Bye.
Nice job.